All right, hello. So, in this video, we're going to go over the solutions, my solutions, to the first homework assignment. So, just a quick sort of note, and I'm sure that you found out that some of these questions do have right answers, right? So, for instance, this one and this one are both sort of right and wrong, right? It's pretty black and white. But some of the questions in 3 and 4 here are sort of open-ended, right? This one and sort of this one too, along with others, that if your answer is different than mine, that's fine. That's fine. So long that you sort of describe what you're saying and what you think well enough, then that's what matters to me. So let's just get into it, and hopefully that we're all on the same page here. So, all right, number 1. So list whether the measure is qualitative or quantitative. Okay, so I'm gonna use QL for qualitative and QN for quantitative. Okay, so let's get into it. I'll zoom in here a little bit too. So the distance from Ross Hall, where my office is, to O'Dwyer's, just a random place that I picked. Totally not my favorite place. So we're measuring something. And it's a distance, and it's in meters. So already that should kind of scream that it's going to be some value. It's going to be some number, and that means that we're working with something that is, we're working with something that is quantitative. Okay, so it's a number, right? Some value. Let's see. B here, whether a person believes in Bigfoot. Okay, so in that case, assuming that this is just sort of a yes or a no answer, and not a question on like some kind of continuum, then we'll say that, okay, that's got some quality to it, right? That's an opinion, right? So in this case, since we're not measuring anything, it's going to be since we're not sort of measuring a value, we're not doing anything like that, we're just measuring an opinion, then it's going to be a qualitative qualitative measure there. So, C, number of hard-boiled eggs one somebody can eat. Number of hard-boiled eggs. So the clue there, just like we saw here, the distance in meters, right? In this case, we're looking at some kind of number, right? Screams quantitative. So quantitative are always values, always some number, okay? And then the next one, opinion on the relationship of Stevie Nicks and Lindsey Buckingham during the production of Fleetwood Mac's best album of theirs and also the best album of all time, Rumors. Okay, if you haven't listened to it, go listen to it. Okay, so we're measuring an opinion here, right? We're getting some opinion, and assuming that it's an open-ended kind of situation and not measured on some kind of scale, we're looking at an opinion that's got some quality toward it that can be used to define it. We'll say that this is a qualitative measure. We're looking at an opinion, right? So the sort of key here is for quantitative, right? Quantitative, typically that's always going to be a number, right? So in this case, distance. Here we see it's a number of something, right? And then again, we can get more specific with these two, right? We will in a second. And then everything else that's not that, right? So like an opinion or your thought on something, that's going to be this qualitative, right? So whether a person believes, right? That's yes or no, I do or don't. Or an opinion on something. I think that their relationship, they hated each other, but I think it was necessary for Rumors to be so good. Anyway, there's a whole story behind this album that's really good. Anyway, that's not what this class is about, so let's move on. Okay, so number 2. Now we're getting a little bit more specific. We are now getting a bit more specific. So we've got 4 options, and we've got to define these 5 things here. Okay, so our options are categorical unordered, okay, categorical ordered, quantitative discrete, and quantitative continuous. So just as a quick review, right, categorical unordered just means that there is no implicit order to it. The order doesn't matter, okay? In the other hand, the categorical ordered, right, so an ordinal kind of thing, the order does matter, that the next thing in the list of choices is either more than the choice before, and it's less than the choice that precedes it. Okay, so let me zoom in here just a little bit. Okay, so let's just look at A first. So the maximum speed of Carson's first car in 1995, Toyota Camry, great car. I miss it. So we're looking for a maximum speed, right? So already this is something that is measurable on like a number line. Okay, so that screams quantitative. And then now we've got some sort of thinking to do. Well, if we're looking at the maximum speed on the speedometer, we know that we can get, pretty granular with it, in that if we were to take the exact snapshot of it, and we'd be able to figure out some decimal point, right? But that's not necessarily, what I think of max speed. I'm looking at the speedometer, and I'm looking at whole numbers, right? If we were in a lab, then maybe we'd be looking at decimal points, right? But for you and me, I think that quantitative for sure, and then I would say discrete, okay? Because we're looking at whole numbers on the speedometer. Now, if you thought the other way around and you said, okay, maybe they're in a lab or something, and maybe the max speed of a Toyota Camry from 1995 is 65.43 miles an hour, then we're looking at something that is continuous. Okay, so really, in that case, it's how you interpreted the question and sort of what environment you thought the speed was being measured. So I would take either QD, quantitative discrete, what I put, or quantitative continuous, either way, right? So I'll just say, I'll put here whole, let me make the pen a smaller size too. Whole numbers. That's what I'm going to say here. And it's okay if you picked whole numbers. It's okay if you picked the other way around too. Okay, so that's fine. Okay, B, severity of the common cold. Okay, so we have this idea of mild. Mild means something, right? If we were to organize these or reorganize these around and kind of move them, then it wouldn't make a lot of sense, right? It would not make a lot of sense. Mild is less than moderate and much less than severe. Moderate's right in the middle, right? And severe is the most extreme, right? So the location of these things matter. So that's sort of telling us that, okay, the order here matters, right? They are ordered in sort of a logical way. And also we're describing something, right? We're describing something, in this case, the common cold. So since we're describing something, we're going to go with a categorical, right? Categorical, okay? And since mild and moderate and severe, they're all in order there, and they all mean something. The order actually means something. Then we're going to be looking at categorical ordered. Okay, so that's cool. Okay, next, percentage of people in the U.S. with a doctorate. Okay, so if just for instance, let's instead of saying percentage, if we said the number of people, that's going to be some count of people. And you're not going to have a decimal point in there, right? Then we would be looking at something that is discrete, right? We're looking at whole numbers. We're looking at whole people, okay? However, that's not what we're doing. That is not what we're doing. We're looking at a percentage. And we know that percentages can be expressed as a decimal point, and often are, right? They've got something in the decimal, right? So that's okay. So already, percentages are always quantitative, okay? And then, since we know that percentages oftentimes are expressed as, sort of a fraction almost, we'll go ahead and say that is a continuous quantitative measure. Again, if we were to change this percentage to actual number, then it would be a quantitative discrete, because we're looking at whole numbers in that case. In the case of percentages, and pretty much all the time, the percentage is a continuous sort of measure. Okay. All right. Moving on. Birth date. Okay, so this was actually in one of the PowerPoints as an explicit thing, and it sort of, it's a little confusing, and that's okay. That is okay. But typically, calendar days are describing something, right? And then does the order matter? Well, the order of days do matter, right? Monday through Friday. Monday represents something, but kind of just a construct, right? That is not something that totally matters, okay? So the order there, and since we're looking at like maybe 11/5, November 5th, I wonder whose birthday that is, or like July 4th or something like that, even though they show up on different places in the calendars, doesn't really so much matter the order, right? It's not like, November 5th to November 6th. It's not like November 6th is everything, including November 5th and everything beyond that. It's not really what that's saying. It's just saying it's a different day, right? It's describing a different day. So we'll say that it is unordered. Categorical unordered. So honestly, the logic behind here, this is probably the most, I think, confusing one. It might make sense to you, and that's totally fine. That's great. And if it doesn't make sense, that's also totally fine. Because time in statistics is fairly complicated. And it's treated differently in different fields. So for now, we'll say that this is categorical unordered just as a rule. When you go into other fields, kind of changes just a little bit. But that's fine for now. So last one, numeric rank of a college curling team. All right. So already we're looking at, well, this is actually a little tricky, intentionally tricky, and it's okay. It's okay that if you got sort of tripped up, totally fine. So we're looking at numeric rank. So first, second, and third, so on and so forth, right? Okay. So we could kind of look at this and say, okay, well, first, second, and third, maybe they represent like points. Okay. So they are describing relative points. Okay. Kind of comparative points. So first had more points than second, but we're not able to really see that difference in points, right? Second is describing that they got more points than third place, but less points than first place. But we don't exactly see those points. We only know that these things here are describing something else, right? Something else. You're kind of just putting them into a box and saying that that's that. All right. Okay. But we do know one thing for sure is that the order here matters. First represents, essentially like all the points that second place got and then a little bit more, right? Second place represents all of the points that third place got and then a little bit more, right? Okay. So actually, I'll just leave that there. We're looking at something where the order matters, and we're looking at something that is describing something, which in this case, I would go with categorical ordered. Now, it's okay if you interpreted first, second, third, or like, first best in the state, second best in the state, third best in the state, then you might be sort of thinking, well, maybe we're looking at something that is quantitative and discrete, right? Maybe we're able to do this for a bunch of other people too. And in that case, I think I'd be okay with either of those answers. I would say that, this categorical ordered is a little bit more on the nose, whereas the quantitative discrete is a bit of a stretch. Either way, though, I think that's okay. So I think this is the better answer, but this is an adequate answer. Okay, so let's move on. I don't want to take up all your time with this. So now we're looking at a survey. So the University of Wyoming wants to determine if adding a mandatory class, birdwatching, would increase students' appreciation for the outdoors. So the university sends a survey to 25 randomly sampled students. Here's the key here. Here's a big thing. From each major. Okay, so randomly sampled from each major. So we're getting every single major that is offered at the University of Wyoming. Okay, and in that survey they ask, what's their opinion on the matter? Okay, All right. So, what's our population? Well, our population is rather limited because anything that we get out of this survey, any inferential statistics, which we have not talked about, in depth yet, but we will for pretty much for the rest of the semester, we'll just say that the population here, well, we can't really apply anything that we find to other universities, right? And certainly not, the U.S., everybody in the U.S. And since, we're sort of limited to the University of Wyoming, we'll just say that the population is, let me do this, is all students at UWyo. Okay. So that's sort of what we're limited to. All right. Now, what's the response variable? Well, what's the thing that we're trying to measure? Well, in this case, it's going to be the opinion on the thing that's being asked, right? On the mandatory class, to keep it brief, okay? Also, my writing is really not good. I'm so sorry. Okay, so that's the response, right? We're trying to figure out what their opinion is, right? So it's sort of asking them what is what they think about, right? So that's sort of the key there. That's sort of the tell. Okay, now, identify the sampling technique used. All right, well, we know that they randomly sampled things, and we'll assume that they properly did it, but they didn't randomly sample a bunch of different people from the university. They looked specifically at each major. They specifically looked at every single major and then got 25 people from each major. So you can kind of think of it as, let's say that, for instance, there are 4 majors. What they did was, and I know there's more than that, but what they did was, okay, you have people here in each box, in each thing, in each major, and then they sampled 25 out of every single one. And what does this look like to you? Okay, so think about it for a second. Hopefully, you did think about it. But we're dividing things up by major, right? We're dividing things into strata, right? And each individual thing here is a stratum. Let's see if I can do this backwards. No, I don't have enough room. But it's okay. So each individual box is a stratum, right? And then each person on the inside is a unit, right? That's fine. It's just some technical terms there. But since we're taking one from each strata, we would assume that this would be stratified random sampling. Stratified random sampling. Now, if you put cluster sampling, here's sort of the difference between that. Is that stratified random sampling takes one from each strata, right? In this case, each major, which is said up in the question. If instead we wanted to do a cluster sample, what we would do is that we would randomly select a whole thing, right? We wouldn't pick each 4 and then pick within that. It's sort of the other way around, where we randomly sample each strata, right? Or each cluster in this case, and then take everything out of there, right? And we would maybe ignore this one and get this one, right? Or something. So cluster sampling is when we take the whole thing, and take everything out of there, right? Stratified random sampling is when we take everything, right, and just pick a few people from every single one. Okay, so that's sort of the difference between the two. No need to get, well, actually, I guess I'll keep that up because that's helpful, maybe. No need to get super hung up on that, but that's the general idea here. Okay, and then identify the type of study. So we're not actually doing anything. We're not doing anything to the students, right? We're just giving them a survey, and we just want to see what they think naturally. In that case, we're looking at an observational study. Observational. Okay, we're not doing anything. We're not doing some kind of experiment on some group of people. Okay. The lead researcher, Barson Leifer, is worried about potential bias of the study. What type of bias do you think there may be? This is an open-ended question. You could answer whatever you think. I'm sure you answered well, too. The first kind of initial thing is that I think that you're going to get a big difference between majors, right? Where you're going to get sort of like in the biology group, maybe, you'll get people that are super into ornithology anyway and would maybe already even take that class, right? So you would get people that are more biased toward liking it, and then maybe you have the people who are in like computer science, or literally any other major that doesn't orient themselves around biology. Then you'll get sort of people saying like, I don't need to do this, I don't want to do this. And then, that's biased in the other direction. So you might not get any sort of, you might not get any kind of leading conclusions. You might just sort of get like half the people were for it and half the people were against it. In that case, you might want to rethink the way that you have your study designed. Anyway, this totally open-ended, so I'm going to leave it blank. I won't. I'll say... no right answer. So whatever you put was good. So long it was well thought out. So that's all good. That's all fine. All right. And then if I design the survey, would you prefer using open-ended questions or closed-ended questions? Well, we're kind of going for the same thing here. So let me do this. Okay. Open-ended questions, the kind of pro with those is that you really get to see the true opinion, right? You're not limited in this case with the closed-ended questions. You're limited to a certain, choice of answers. Now, in this case, we're just sort of asking like a yes or a no question. So we might get very similar answers, very similar conclusions, I'll say. But if the question were a little bit more complicated, a little bit more convoluted, you also have some people that, with the open-ended questions, you might have somebody that comes in and says something very elegantly, right, and very detail-oriented, and then someone else who believes the same thing, but describes it in a different way that might be misinterpreted, right? So that's kind of the issue with open-ended questions, is that there's some interpretation there that might get missed, right? There are also, you may be, it's kind of harder to find information with the open-ended questions. Whereas the closed-ended questions, you're able to very much make sure that, what they think is reflected in that closed-ended question in their choice, but you might be missing out on some of the more nitty-gritty details, okay? So again, no right answer there. Totally what you think. That's what I think. What I just described is what I think. So no worries there. Whatever you put was probably good. Okay, so moving on. Here's a paper. Here's a link. I've got it attached down here too. So I'll go read it real quick. But I've got some questions regarding this. So identify the study population. Well, let's recall. I've got it down here actually. Here we go. Identify the study population. Well, the authors followed, I've got it, down here. The authors followed 1,000 some odd people in one town in New Zealand. Now, the sort of key here is that it's almost virtually every child, right? So almost everybody was followed. Okay, that makes this question, where are we? That makes this question a little difficult. That makes figuring out what the actual population is a little difficult. So I think that you can kind of think of this a few different ways, and this is more open-ended than I may lead on. But the population here is, it's mostly limited to that one town. What's the actual name of the town? Dunedin or something? Yeah. New Zealand. That one town. That's sort of that's like a conservative. Oh boy. Conservative. That's kind of a conservative population. Maybe you could think of it as on a liberal kind of side of things, not conservative and liberal as in like political, but just actually what they mean. We could maybe say that, or all of New Zealand, maybe. It's kind of a liberal estimate, right? So that's a population that a little bit up in the air, right? Now, certainly, we would not be able to say that this is applicable to the whole world, right? Because that's just it's too wide of a frame. We don't have enough information. Certainly that, the population of Dunedin, New Zealand, or Dunedin, however you say it, is probably, not totally representative of, the average of the whole world, for instance. So we'll say for now that the population is this one town, okay? And we might be able to associate anything else on a little bit of a larger scale, but with that caveat being that we don't really know, okay? Okay, anyway, the response variable. Okay, so the response variable is explicitly stated, which in this case it was IQ. But how does one interpret this variable? Is it easily understood and calculable? Does everyone have access to it? How accessible is it? Well, how do you interpret this? I really don't know. I really don't know. There is an IQ test, and I assume that that's what they did for this, these 1,000 people or whatever. But how is that really calculated? It's not the easiest to understand. It's you take a test and then whatever your score is your IQ. But how is that calculated? I don't know. Do I know my IQ? I don't. I do not. And you probably don't either. Very few people do. Very few people do. Because there's really only one, even though there's a bunch of tests online that say that it can calculate your IQ, there's like one test, right? And I don't think it's that accessible. So, the rest of this is sort of open-ended. So let me write that too. But I would go ahead and say that this is maybe not the best thing to measure. This is not the best thing to measure. So open-ended. Okay. But the big sort of take-home here is that it's maybe not the best way of measuring intelligence, right? There might have been something else that they could have measured that would give us a little bit of a better idea of what's going on, because IQ is just sort of out there. It's not the easiest to understand. So that's fine. We'll move on. But there's plenty of ways you could have interpreted that, and that's fine. Okay, identify the sampling technique. Well, if you come back down here, we know that they just looked at this one town, right? And we'll assume that they randomly sampled. I mean, they got everyone out of the whole town, so it's not even really like they sampled anything. They almost just took the whole population of that town and followed them. So this is a bit tough. It's okay. I'm just gonna go ahead and say that it's a simple random sample, because they didn't really explicitly state anything. Simple random sample. Okay. The shorthand for that is SRS. All right. Since they didn't explicitly state anything, we'll just assume that this is what they did. Now, if they went around and, divided up all of New Zealand into towns and then randomly sampled each town, then that would be more of a stratified kind of thing. If they divided it up into towns and then sampled whole towns and left out a couple of other towns, then we're looking more at a cluster situation. That's not what happened, though. We're looking at something that's a little bit more of a simple random situation, with that caveat being that they got almost everybody, so it might not be sampling might not be the most accurate way of describing that process of choosing. Okay, identify the type of study. Well, again, we're not doing anything experimental to these people. We're not giving them marijuana. We're not splitting them up and then doing something to one of the groups and not to the other. We're just looking at what happened naturally, right, over some period of time. So we're going with observational for this one. Okay. So this is sort of question E here is sort of reflected in question C, but state any issues that are mentioned with the sample. Are they adequately selected, generalizable, large enough? Well, I think down here even, they say that, let's see, yeah, here it is. Zoom in just a little bit. So one of these scientists is skeptical about how generalizable the results are, right? Which in this case, because they just got that one town, that's sort of one big sort of red flag there. Also, another red flag, and I've got it highlighted here, is that only 38 people in the study used marijuana heavily to be diagnosed with dependence, right? See that here? So that means that, out of this 1,000 people, some odd people, only 38 of them were considered dependent, right? Which is sort of the whole idea with this study. The results there might not be the most, generalizable, I'll say. So adequately selected, sure. They got the whole town. Maybe not. It's definitely not the most generalizable. If they got maybe a bunch of different people from a bunch of different towns in New Zealand, that's a different story, right? Is it large enough? Well, that caveat there being that there's 1,000 people, which certainly is enough people. Certainly is. Only 38 of which were dependent on marijuana. That kind of throws things off, right? That big jump between 1,000 people to 38, that is sort of a red flag there. Now, one thing in statistics is, generally you see that a good sample size, and I'll write this in purple here. A good sample size is around 30. Now, that is the moment you go into other stat classes above this class, that gets thrown out the window. People hate saying this, but for now, this is sort of an okay rule. So it's about 30. We saw that those 38 people who were dependent, that's close-ish to 30, right? It's a little bit more than 30. Let me write this too. The larger, the better. We'll get more. We'll get into that actually next week, regarding the whole sample size thing. But typically around 30 is decent, and then everything above that is good. Now, we've sort of already talked a lot about the sample selection here, large enough, generalizable. Again, this is totally open-ended, so I'll just leave it at this. And if you want to talk more about it, let me know and we can set something up. Okay, and then what issues do you have with this study? Probably all oriented around this idea of how they selected the sample. There's also some issues in here too, where like the IQ that's not an accessible thing. That is not an accessible thing as far as a measurement goes. There's another thing in here too. We have these ideas of. Oh, actually, let me write this in orange. So factors that, and by factors I mean things that are also involved that we don't really see, things that are involved in some kind of study that are not explicitly measured that may affect the outcome in some way, which we see here. The example is given as child abuse or other trauma. These would be considered. Man, let me make this smaller. These would be considered confounding variables. Things that affect the outcome but that are not explicitly measured. Okay. So that's something that you could have an issue with too. Maybe they didn't account for that. I don't think they did. So there's other things that affect IQ, not necessarily the thing that we're measuring, as far as marijuana goes. And we sort of see that highlighted down here too. Let's see. There's another thing that I wanted to talk about. Let's see. Oh yeah, here. And we'll get into this following, depending on when you're looking at this video, when you're watching this video, you may have already be familiar with it. But let's see. Where did it go? Here it is. We see this word average used. Okay, and we know from last week, briefly, I mentioned that average can represent three different things. Average can represent the mean, the median, or the mode. Okay, so the mean is, generally it's just summing up everything and dividing it by how many things you have. So more or less kind of an expected value. If you point at somebody and say, I expect you to be whatever the mean is within some range, then you're probably going to be right within some error bound. Okay, and then the median just represents the halfway point, right? So everything below that value represents half of the data, and everything above that represents the other half. Okay, so the median is some value that just splits up, right? 50-50. And then the mode is the most frequent occurring, okay? The most frequently occurring number. And oftentimes they're right around the same thing, right around the same value, but not all the time, right? And they tell you slightly different stories too. And we see here that average intelligence, okay, what does that mean? Well, they don't explicitly state whether it's the mean, the median, or the mode, but they do say here in the quotation marks, or in the parentheses, an IQ score of 100, the 50th percentile. The 50th percentile here. Okay, and what that means is that all of the values below this represent 50% of the data, and all of the values above it represent the other half. Okay, and by the brief description that I gave about, these three parameters here, the median is the most likely what they measured, because we're looking at this 50th percentile, right? Would the mean and the mode look different? Who knows? There's a reason why they chose this 50th percentile. Okay, maybe the mean and the mode told a different story that doesn't necessarily fit in with what they're trying to suggest here. So, just keeping that in mind. There's so many things that go into it that it can get pretty complicated fairly quickly too. So this is also open-ended. Okay, moving on to the last question. Okay, so the thing here, BBC reported that on average, college students drank 33 ounces of alcohol per week. Okay, 33 ounces, so that's like, what is that? 15-ish drinks, maybe, a week? Wow. Okay, whatever. So CNN picked up the story because in the U.S., the average is only 24 ounces, right? Okay. So we're kind of comparing two different groups here, at least in this initial sort of assessment. Assume that we wanted to test that if the average was, if the average was different for University of Wyoming students. Okay, so the university hires some surveyors and they randomly select 100 students from the athletic department of the University of Wyoming. Okay, so 100 students in the athletic department of the University of Wyoming will assume that there are more than 100, right? We'll assume that there are more. It could be 101 for all we know. They find that the average in the athletics department is 16 ounces per week. Okay, the average based on this random sample of 100 students. Okay, what is the population these results are valid for? Choose from the following. Okay, well, we can go through each one. So let me do this. Okay, let's start. All students at the University of Wyoming, all people in the state of Wyoming, college students in the U.S. So it's sort of going increasingly here, and then all students in Wyoming, all college students in Wyoming, so on and so forth, right? So the idea here is that we are limited, right? We are limited to the athletics department because that's all we sampled, right? For some reason, maybe they were the most accessible. Maybe the surveyors knew that they would get, good answers, right? Truthful answers. Maybe not. Maybe there's some bias there. So since we are limited to the athletics department, we're only able to conclude anything about students in the athletics department, right? So all students. So any conclusion we make from that study is only applicable to the athletics students at the University of Wyoming. Now, I'm just now sort of seeing this. Let me make sure that I've got the correct thing here. Yeah. So athletic students, that's not describing like students who are athletic. This is meant to be students in the athletics department. Okay. And now that I'm seeing that, I'll be a little bit lenient on sort of the other choices here. But that's the most correct answer. I know you hate this too, that there's varying levels of correctness. That's sort of what this first week of statistics is going to be like. You have more correct answers than you do incorrect. But let's look at the other options here and just get an idea of maybe other sort of correct answers. So we can maybe stretch and say all students in Wyoming. Maybe. No. Actually, before that, all students at Wyoming, University of Wyoming. Okay. And then maybe stretch even further. So I'll this is the first best. And this is maybe the second best. If we're trying to really stretch, all college students in Wyoming, right? So there's other colleges in the state. Maybe we could say that about them too. Big time stretch though. And then after that, that's about it. That's all I would be comfortable with doing. I think that's still the best here. The best here is the athletic students at the University of Wyoming, specifically those who are also in the athletics department. And then everything after that is a bit of a stretch. Okay. So if you want to chat about that, let me know, because the last two questions here were very much open-ended. And I promise that on the test, they will not be so open-ended. Okay. Syllabus questions. So hopefully we're all on the same page here. What day is homework assigned? That's going to be that Sunday night. When is it due? It's going to be the next Monday. All right, so you have 7 days to do that. What day is the discussion / participation stuff? When is that assigned? Also on Sunday. Due on Thursday. All right, so hopefully you've already got that figured out. On test days, what time can you start the test? Well, it's 9 a.m. And then we can finish it at 9 p.m. That's when it's due. It will not take you 12 hours to do it, I promise. But that's just, since we're online and people are already stressed out enough, 12 hours is totally fine. Okay, and the policy on late work, no late work. Okay, sweet. So that's that. That is that. Some of these questions had right answers, had wrong answers. Some of them were more opinion-oriented. So either way, the test will be a little bit more discreet as far as correct answers, and you'll know you won't have to stretch any of your ideas or anything like that, I promise. So with that, hopefully you feel like you did well. If you feel like you didn't do well, that's fine, and just let me know, and we can chat about it for however long you want. So with that, I will stop the video, and I will see you in the next one.